Hi, welcome to WOW TV. My name is Angel, and I'm here from the Wizards of Wright program. The WOW program is a part of the Educational Outreach Office here at Wright-Patterson Air Force Base. Today, you're going to experiment with circuitry. Are you ready to get started? Let's go. In order to understand circuitry, it's important to understand electricity. Electricity is a form of energy. When electrons flow from one place to another, we have electricity. There's the kind of electricity that we use at home and at school, like when we use batteries and outlets to turn on our TVs, our computers, our refrigerators, lights, and cell phone chargers. This is called current electricity because electrons flow in a current. There is also something called static electricity. This is when the electrical charge builds up but doesn't go anywhere or flow. You've experienced this when you get a tiny zap from rubbing your feet on the carpet or when your clothes have static cling. All the way back in the 1500s, it was discovered that objects charged with electricity either moved towards other objects with a charge or moved away. This means they were attracted, there was a pull, or they repelled, they were pushed away from each other. But how do the electronics around us work? All matter has atoms, and when the electrons move or flow through our devices, they produce a sound or a light or another effect. Now, what have you already learned about circuits? Have you learned that for electricity to flow, you have to have a circuit, a complete path, and that there needs to be a source of electricity, like a battery? Materials that allow electric current to pass through them easily are called conductors. The conductors are used to link the positive and negative ends of a battery, and this creates a circuit. Conductors allow a current or electric charge to pass through easily. The opposite of that is an insulator. It doesn't let a current or electric charge pass through easily. Plastic is an insulating material, therefore it doesn't work as an electrical conductor. It stops electricity from flowing to places where it is not needed. We also need to understand the difference between an open and closed circuit. In an open circuit, also called a broken circuit, there is a break somewhere along the line, and the current of electricity cannot flow all the way. The current stops. In a closed circuit, also called a complete circuit, the electric current can flow all the way through. When a circuit is closed or complete, electricity can flow. That's how the devices and appliances in our house work. We can turn on a light bulb, the TV, or our computers, and the electricity flows. Not only is it important to understand an open and closed circuit, we also need to know the difference between a series circuit and a parallel circuit. Let's use the word resistor in our explanation. As we know, a circuit is a complete or closed path where electricity can flow. A series circuit means there is just one path for that electrical flow. In a series circuit, everything is set up in a line, one after the other. A resistor is something in the circuit that limits or lessens the amount of current flowing. Let's look at an example, with the resistors being bulbs. If at any time one of the resistors stops working, the entire circuit will not function. For example, if one of the light bulbs stops working, all of the other light bulbs will also stop working because the path of electricity is broken. Do you put lights on your Christmas tree? If the lights are in a series circuit, one burned out bulb means none of them will work. One advantage to this is that you'll always know if there is a break in a series circuit. The disadvantage is that if there are many bulbs in a circuit, it's very likely that the light will be dimmer because the voltage is split across all of the resistors. When the resistors are not in a straight path, but on different paths, it is called a parallel circuit. There is still more than one resistor, but they are on different paths or branches of the electricity flow. Think of all the light bulbs and appliances in your house. If one light bulb stops working or burns out, everything else can stay on because the electricity is not flowing through one path. This is because your house is wired with parallel circuits. Let's pause for a few minutes as you review the important vocabulary used when studying electricity and circuitry. Teachers, please pass out the vocabulary sheets and determine if you want students to work on their own, with a partner, in a small group, or to do this all together. After the sheets are completed and you've gone over the answers, I'll meet you back here. Now that you can use that list of words correctly, let's get ready for your next activity. Think about what you've learned about using a map and a key. If someone asked you how to get to New York City, how would you find the answer? You'd probably pull up an app on your phone and search for it on the internet. Both of those solutions are using maps, which are important in helping us find locations, learn about geography, or learn about the natural features of the Earth's surface. Most maps have something called a map key or a legend. This is almost like a code to understanding what the parts of the map mean. The key uses pictures, different colors, or lines to represent important places or landmarks on a map. They are usually located at the bottom of a map. For the second activity, teachers please give each student a circuitry map and a red, blue, and green crayon. We'll pause again while you work, and after the sheets are completed and you've gone over the answers, I'll meet you back here. Now, let's connect what we just reviewed about maps and keys to circuits. Just like using a map key and symbols, engineers use symbols with circuitry. We have a handout that will help you learn what the symbols mean and how to read and write with circuitry. Teachers, please pass out just the handouts now. Let me show you the circuitry kits you'll be using. In the kits, you'll find 10 ceramic magnets covered with aluminum foil, some Christmas lights, 3 of these single bulb strings, a double bulb string, and a triple bulb string. You're also going to find a plastic tube, a DC motor, a switch, 3 extension wires, 2 alligator clip extensions, and some AA batteries. Teachers, before I turn the remainder of the lesson over to you, you may want to show students how to draw and build the circuits based off of the symbol sheets, possibly doing the first couple from the worksheet together. When you're ready, pass out the circuitry packets and the kits to the students so that they can complete the rest of this lesson. Please remember that what we did today was safe and controlled, but you should not experiment with electricity on your own or experiment with your appliances or power outlets at home. This can be very dangerous. Thanks for joining me today. And teachers, thank you so much for using this WOW lesson. Please check out more at our website at wpafbstem.com.